Start the game. E4. Knight to F6. Bishop to C4. Knight captures E4.
So here we are playing chess and the video is being captured by this web camera over here, and then our computer vision algorithm is detecting the move. So you can see the board with the moves played over here and what camera sees and how it able to detect. And yeah, if you are curious about this particular opening, here is my gambit against my father.
Bishop captures F7 check.
Before we start this video, here is the important disclaimer. So I am not the first one to try or solve this problem. This has been solved by multiple people using different approaches across the years. And even the full-fledged products exist on this problem. In fact, the early research on this computer vision chess move detection were begun way back in year 1997, the year when I was born. So I'm not the first one, but this video is about my approach and some of the interesting and creative challenges which I faced along this journey and about how I solved it. So it's not perfect, of course, but let's see what it is. Why do we want to detect the chess moves? Well, for first thing, what is the meaning of a chess game if you forgot all the moves, right? In fact, if you are playing a serious chess, you should always write your move. This is the general advice in the chess world. You should always write the moves. I also do write the moves of some of my games in this format. So you should always write the move. But even if you are writing the moves, nowadays what you are probably doing is entering that moves back to the computer or your mobile app to analyze the game, right? So this is kind of a doubled effort. And in top level games, they use electronic chessboard which looks something like this. And this is not based on the computer vision, it is based on the sensors. They are basically measuring the weights of the pieces and detect the moves. But this board is something like people like you and me cannot afford. And also one more thing, we need this clock to play chess at a high level. So this is also required. But so this detection can obviously eliminate this clock as well, because if it can detect the moves, it can obviously record the time, right? So it kind of solves this both of these problems. So these are the benefits, and I have been playing chess since very young age. I am not that strong in chess but have some experience in playing at professional level, and I wanted to try out this problem since very long. But earlier maybe I was lacking some of the core technical skills, but then I started my career as a software engineer and over the years got some opportunities in machine learning domain as well. So I have been now working on this since last month in my free time, and I have a working solution ready, but still I believe there is a long way to go before I sleep. Okay, so as I said, there can be various different approaches and people have tried tons of different things, but here is how I break down this into 5 different pieces. So the first one is handle the camera using our code. Then second one is extract out the chessboard from that image, and then what we can do is divide that image into 64 distinct images, one for each square of the chessboard, and then we can design the algorithm to detect the moves using those 64 images. And the last one is some decoration, like computer can speak out the moves as we saw, or it can show the chessboard. Various things we can try. Okay, so this is my breakdown. The first step actually is very straightforward, and CV2 library of Python provides all the required things to control the camera. And by the way, I am using Python for all this implementation, and here are some of the libraries which I have used. First, let us understand what do we get as an input. So we can get this kind of an image in our camera continuously in the input. But so one thing I realized after experimentation is the camera position is very important. So for example, we are getting image like this, then this problem is a bit difficult. But what do we really want is the image like this from the very top down view, and then the problems becomes bit easy. That means we should put our web camera like this, where it can see this top down view. So this is what our camera sees right now. So as you can see, it's from the very top. And in that case, for example, let's say this pawn is here, then as you can see, it's very difficult to detect this pawn even for human eyes, because this is what the camera sees. So that's why it is important to see like this. One more thing to mention is, for this problem, camera resolution is not as important as camera position. For example, this 170 progressive HD web camera is just having 0.3 megapixels image, not even 1 megapixel, but it can still do the job for us. From this camera image, how do we detect four corners of the chessboard? If we can detect, then we can easily divide them into 64 separate images like this. But this first problem is difficult than our initial expectations, especially with to generalize this. Like, one approach could work for one type of a chessboard but not for the other. So I have tried a lot of different things, and I will quickly discuss them. So here are some of the things I've tried. I will not get into the details in this video, and also I can show you my literature survey around this problem. So if you want, you can pause the video and see those. Well, some of the things worked, but not always. So I have finally decided to go with the simplest thing which I can, is manual human inputs, or we can call it a calibration. So CV2 provides this kind of tools where you can zoom in or drag on the image, but you have to click on this 4 dots whenever you readjust your camera or the board. So while it's not big deal to click on the 4 dots, but I would love to automate this. Let me know your suggestions on this. So assuming now we have divided whole image into perfect 64 squares, so now we have image for each of those 64 squares. So let's say for the square which is having pawn, we will have image like this. For the empty square, we will have image like this. So now let us think on the algorithm to detect the moves. So the initial expectation is we will have to detect whether the square is empty, or it is having pawn, or it is having bishop or knight or king or queen. So or whether it is a black piece or white piece, right? Or maybe we can do something simple than that. So I want to encourage everyone to pause this video here and think about this. What will you do here? So
actually the idea here is we only need to detect whether the square is empty or it is having white piece or black piece. And by piece I mean any piece, pawn or any piece. We do not actually need to detect the type of piece in order to predict the move. So this is the creative idea which I had earlier, and I was very happy with that idea, and in fact that was the reason why I have started working on all this. So this might seem obvious to many people, but if it is not, let me explain that further. So let's say we start with this. Obviously this is the initial position for any chess game. So we know like all of these squares contain white and all of this square contain the black pieces. Now let's say we play this move e4. So we will able to detect that earlier this square was empty, now it is having white piece, and earlier this square was having white piece and now it is empty. So that way we can detect the move this is e4, and we don't need to detect whether it is having pawn or any like knight or bishop or anything else. Similarly, let's say black plays d4, and after that we capture here. So now if we can detect earlier this square has black but now it has white, so we can predict this capture. Another idea could be just detect whether the square image has changed or not after every iteration. So this idea is also perfectly fine, but after some digging I realized that the first one is more robust, especially with the cases where we have lights from the one side and we have a shadow of one piece on the other square.
To perform this algorithm move by move, initially what I did is sort of a manual effort, like you move and then press the space, and then it will capture the image and it will compare that image to the previous move's image. So it like move and press the space
e4,
and so on. But after that I was able to automate this, like now it will capture the image continuously and capturing the updated image with that last move's image, and whenever it detects any legal move it just makes the move and capture that image to compare further. So it is like
e5,
sort of a working live now, even if it's
knight to
very fast, it
f3,
able to detect. So no need to press the button after every move now. So all the chess players are pressing this button after every move. So even with that manual mode we are okay, but this is automated. Can you make a move by the way?
queen to
Oh, this
d5,
is stupid move, I mean.
knight capture,
And by the way, I have implemented undoing last move functionality. So you need to press the U. So it works like
undoing
this.
last move,
So the final piece of question is, given this image, how do we detect whether it is an empty square or it has white piece or it has black piece? So again, many different approaches are possible. I've tried a couple of things. Even the simpler solutions can work here, but we would like to make this more accurate and as robust as possible, because this is the core of this whole problem. So finally I have decided to use the machine learning model to do this. We need a model which can achieve very high accuracy on test data with very less amount of training data. So let me show you my final version of the model. So I am using TensorFlow sequential model. So the input image shape is 64 cross 64 pixels. So as I said, this is not a very high resolution. The width and height of this image is 64 pixels, and not talking about 64 different squares. This is just 64 cross 64 pixel for each of the squares image, and it is colored, so it has this 3. Then I have basically convolution layers followed by max pooling layers, and in the end it is basically a classification problem. So it has dense layer of 3 neurons. So the first one is for empty square, the second one is for white square, white piece, and the third one is for black piece. So this is basically how it looks, and this is the plot of that model. Now, how do we train the model? So I played one game of chess and I captured all these images and saved all the moves. So I have to give the moves to the training data. So now the beauty is it works with this very less amount of training data. So my game, I just played 16 moves, which means in the chess terminology we have 16 moves. So one for white, 16 for white and 16 for black. So in our terminology we have basically 32 moves to predict, and for each of the moves we have 64 squares images. And now as a data augmentation, what we can do is we can rotate those images in all 4 directions to make the model more robust. So by having just one game of 16 moves, I can get the training data of 8,000 images. So this is how we can train the model. So here is the training shape, and here are our labels. So yeah, as you can see, even with the 5 epochs, it is able to achieve very high accuracy. And now I will not get into much details, but then using those changes detected, it just predict the moves. And I have also plotted the intermediate convolution layers, how they look. I am not able to understand what they are doing.
So the good, the bad, and the ugly about this model is, let's say you have training data just on this kind of the environment and chess mode, then it might not work for this different kind of the pieces. But then what we can do is play a very small game of predefined moves in that kind of pieces, and then it is quickly able to achieve the accuracy on that using that combined training data. So in a way we can have a lot of different environments in the chessboard, and we can regularize the model.
But yeah, for now this model works. It rarely fails, and I'm happy with that. And then we can do a lot of extra things, like I am showing that chessboard on the screen using this chess module of Python, and we can use this text to speech model to speak out the moves. So not getting into much details in this video, but one thing I want to mention is from that text to speech model we can use the threading, just that it will not block the actual execution while speaking. Also, one more interesting function I had to implement is from this kind of a move, we will get this kind of a move from chess module, but what we really want to speak out is this kind of a thing, like from n cross e4 hash. What we really want is to have this kind of a string, knight captures e4 check and mate. So not able to find this functionality anywhere, but so it was fun implementing this kind of a function. It has more corner cases than I would expect.
If there are people who are interested in my code, so as of now I don't want to make it public. It is not very readable, and I would like to do lot of improvements going forward. I will make it public someday later. but if you are interested, please reach out to me. The purpose of this video was to give you all a basic idea about what I have been doing and to request everyone from my chess community and software engineering community as well as machine learning engineering community to provide your valuable suggestions. I would love to automate that calibration part. I would like to make this all more robust. So please provide your suggestions. And if you have enjoyed the video by any chance, then please add a comment. It would mean a lot to me. And thanks for watching.